DFG Science TV. The Wave Hunters. Do Einstein's gravitational waves rock the universe?
When two black holes collide in space, the entire universe is shaken. Space and time begin to vibrate, and gravitational waves are formed. According to Albert Einstein's general theory of relativity, these gigantic events affect the properties of space and time. The observation of gravitational waves will provide mankind with a never-before-seen view into the universe and create a new type of astronomy. But the search for direct proof continues. In order to experimentally verify gravitational waves, we find ourselves in a particularly charming situation that requires us to understand the physics of the smallest particles, namely quantum physics, in order to develop the measurement technology needed to learn something about the largest thing imaginable, the universe as a whole. At the Albert Einstein Institute and at the Leibniz Universität Hannover, researchers within the Quest Cluster of Excellence are both studying the fundamentals of the general theory of relativity as well as exploring the experimental consequences and applications of these fundamentals in astronomy. The AEI is probably the only place in the world where the entire range of Einstein's legacy is represented at one institute.
Von Einsteins Erbe in einem Institut vertreten ist.
More than 100 researchers from all around the world are working here with the goal of measuring tiny signals from gravitational waves. Among them are Henning Farbruch and Alexander Khalidowski. They are making an important contribution toward using the large GEO 600 gravitational wave detector to find this first direct proof. Their work is helping to improve the sensitivity of the detector. A great challenge, but the motivation of the researchers is even greater. I came to AEI in search of an interesting place to complete my diploma thesis. I was immediately fascinated by the sight of an empty optical table in an empty laboratory. In the meantime, I have filled a number of these tables with components and performed many experiments. I was actually able to obtain and document results that no one had ever obtained before. By combining the output of many experiments, each of which has explored a field of new physics, experiment is now being assembled for GEO 600 that combines all of the advantages and innovations of the individual experiments. It hereby represents a particularly interesting light source for gravitational wave astronomy for the detection of gravitational waves. For many years now, scientists have been aware that using normal laser light will not suffice in making gravitational wave detectors more sensitive. The work of Henning Farbruch and Alexander Khalidowski is especially important here. They are going to install this very special artificial light in which the photons arrive uniformly like beads on a string in our large gravitational wave detector, giving it even better sensitivity and thereby enabling us to peer deeper into the universe. No one has accomplished this yet. And in the day-to-day life of a researcher, it is a source of quite some excitement. How Henning and Alexander are going to improve the gravitational wave detector GEO 600, you will see in the next episode.
Visit DFG Science TV for more information. Awaken the researcher within you.